Hi, class. So this is going to be a lecture on a mathematical treatment of vectors and breaking them down to their components. I'm going to start off with a two-dimensional Cartesian coordinate system, just here. And this will be, we'll call this y. That's y, that's x. And then we'll draw the first vector here. So that's going to be our first vector. And like before, we're going to call that A. Call that A. Okay, so what we can do here is we can actually break down A into its components like we did before. And so we can break it down into a component there along the x-axis and a component here along the y-axis. And so what we'll call these is, this is going to be A as well. It's a little bit bigger. And that's going to be AX. Actually, that's going to be AX. Then we'll do AY here. It's an A. And those are also vectors. You can see that they go, they each have a direction and a magnitude, specifically along the axis. So the subscript x is always going to be along the x-axis, and the subscript y is always going to be along the y-axis. And adding vectors like we did before, we can add x and we can add y, and that'll give us, add a sub x and add that to a sub y, and that'll give us A. That's a little small. Make that one bigger. All right, cool. So what this will be is, and I'll add the, like usual, add the A's and stuff later. Okay. It's going to be AX plus AY. It's going to equal A. That's going to be X. Actually, we'll do bold. It's still too small, actually. There. And then Y. And these are all vectors. Okay, so that's basically how that math works there. Now imagine, suppose we're given the vector A here, and we need to find AX or AY. We know that this angle from trigonometry, that angle there, so that's going to be theta, and I'm going to write that as and then to make that theta, So that's theta there. And if we want to find that, we should remember our equations from trigonometry. So I always remember it. Here's the way I remember it. And I've used this ever since grade school or middle school or high school or whenever you learn it. It's SOHCAHTOA. So S-O-H, so S-I-H, SOHCAHTOA. And so that's is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's how I always remember it. So I'll write this out now. So sine, and I'll make that into an angle, sine is opposite over adjacent. Cosine is adjacent over hypotenuse, or over opposite, sorry. And tangent is opposite. Oh, I'm sorry, that's hypotenuse. So that's hypotenuse, and then this is adjacent. Okay, I'll draw those real quick. Okay, so if we want to get this line, we can figure that out by, well, okay, so if we want to figure out what AX is just by A, so we know that we're going to know this, the hypotenuse, and we want to find the adjacent angle. Since this angle is adjacent to AX and we know what A is, then to find that, so AX, and I'll put the X on there later, is going to equal A I'll just do it, and I'll do it in red. Cosine theta. That's going to be the angle of that, and that's going to be AX. So it's going to be X is going to be that. And then AY. Y is going to be opposite of the angle, and we know A is a hypotenuse. So that will be, and I'll put Y in there. And I'll put the Y in there like usual. A sine theta. Okay, and then, yeah, that's a theta. Fix that one. Okay, so that is how we find AX and AY. So if we want to go backwards, if we want to find this angle here, and all we know is AX and AY, then we know the opposite and the adjacent angle, or we know the opposite and adjacent side. So then to find the angle, we'll have to take tangent of that. So to write that out, the angle I'll fix that. The angle is going to be tan, and it's going to be to the -1, which is like -1. And I'll fix that in a sec. It's going to be AY over AX. Okay. Fix this up. Okay, so then that's going to be our equation for the angle. And actually, I'm sorry, I have that backwards, because that is opposite, which is going to be y over x. Okay, and one more thing that we can find is we want to find the length of A. So that's going to be a little bit more complicated. It's going to be the Pythagorean theorem. So A squared. I'll fix that on the end like usual. It will be AX squared. So it would be like that if I typed it, but that's confusing. There's actually a typo in your book, so that's why I'm doing this, to make sure I have it right. Okay, so we're going to have squared. And then we're going to have x subscript here, and a squared, like that. And we're going to have a y subscript and a squared there. Okay, so that's squared. So if we really want to figure this out, we'll need to do a square root for A. Do all these again. You can find this in your book, but doing it right here, and then a square root. Okay, so that's how we break down vectors into components and how we find each component from a vector, the angle and the magnitude. And this is actually the magnitude here. Sometimes the magnitude is written like this, but in our book it doesn't use that. So that's good for the first part of the math treatment of vectors, and I'm going to do one more on vectors where I'm going to add them by their components, like the book. Thank you very much, and one more lecture on vectors.